Welcome to this demonstration of the central limit theorem. We're going to explore how sampling distributions work. First, we'll start by setting our parent population to a uniform distribution. Notice how the data is spread evenly out in a flat block across the top graph. Let's take a slow, animated sample. The tool randomly selects 5 individual data points, calculates their mean, and drops that mean into our middle graph for a sample size of 5. Now it does the exact same thing, but this time drawing 25 random data points. It calculates the mean of those 25 points and drops it into the bottom graph. Taking just one sample isn't enough to see the magic. Let's speed things up and pull 10,000 samples at once, a few times over. Look at what happens. Even though our original parent population is totally flat, the distribution of our sample means forms a classic bell curve, a normal distribution. Notice how the bottom curve, representing the larger sample size of 25, is much narrower and tighter than the curve for a sample size of 5. Now, let's try a skewed parent population, where most of the data is heavily bunched up on the left side. We'll jump straight to pulling 100,000 samples. Watch the graphs below. For a small sample size of 5, the distribution still looks a bit skewed and asymmetrical. But look at the bottom graph for a sample size of 25. Despite the original data being heavily skewed, the distribution of the sample means is remarkably normal and symmetric. This is the central limit theorem in action. To really push this theorem to its limits, let's create a crazy, custom parent population. We'll draw a totally irregular shape with multiple random peaks and valleys. Let's run a massive 100,000 samples. The middle graph, with a small sample size of 5, still shows some of those weird irregularities from the parent data. But our bottom graph? Once again, it perfectly forms a smooth, normal bell curve. So, here is the incredible takeaway of the central limit theorem. No matter how weird, skewed, or irregular your original population is, as long as your sample size is large enough, the distribution of those sample means will always approximate a normal distribution.